Hello and welcome back to Calculus 2. This is the second part of 610 on hyperbolic functions, and we're going to look into calculus. Now you can take the limit, you can take the derivative, and you can do the integral for hyperbolic functions. Now, the power of hyperbolic functions is that they have two forms. You have the form that is written as sine hyperbolic or cosine hyperbolic, but you also have their exponential formula, right, the entity. So you can deal with the problem from either of the two perspectives, whatever you find either easier or possible, because in some cases it will be very challenging to grind through a problem one way rather than the other. So what we are going to look at first is that the derivative of sine hyperbolic x is cosine hyperbolic x, and the derivative of cosine hyperbolic x is sine hyperbolic x, so no negative. That's really cool, right? And then we have the derivative of tangent hyperbolic x. What would that be?
Secant squared.
Yes, hyperbolic. So tangent hyperbolic x is going to be secant hyperbolic squared x. Now these would be the main ones. Now we also have the other three, but most of the time it's this. And you absolutely need to memorize these to survive differential equations and other courses that are coming up. Now, the next would be cotangent hyperbolic x, which is negative cosecant hyperbolic squared. And then we have secant hyperbolic x, yes. Secant hyperbolic x, tangent hyperbolic x, and cosecant hyperbolic x, so all of them are important, but as I said, the three on top are the ones that pretty much show up all the time. Now all of the standard rules that you learned for product rule, quotient rule, chain rule, logarithmic differentiation, all of it applies here. I would like to present a quick exercise where you can prove that the minus sign does not appear in this formula like it does for trig. Right? You are used to have negative sign when you take the derivative. Well, it's very simple to show that, because all you need to work out is work it out from E form. Take the derivative, just a basic derivative. I just noticed that I missed the minus sign, guys. right here on the secant hyperbolic. The top three are all positive, the bottom three are all negative. So everyone, on the middle formula, this one, make sure you have a minus sign. All right. So what do we have here? We have 1/2 will stay 1/2, right? Because that's a constant. And then derivative of e to the x is e to the x. And derivative of e to the negative x is negative e to the negative x. So isn't this? Exactly. So see how there's no negative that pops up. So let's do some chain rule. See you next week. What happened? Oh, done? Okay. So what's the derivative of tangent? Secant squared. Good. So we have secant hyperbolic squared of 3x to the 5 and then times 15x to the 4th. Very good. That's the chain. One more. What now? Perfect. Product rule. Go. It's not going to fit over there, so next line. So what should I write? Yes, the very important thing. Factor out what you can, because eventually you have to set it equal to 0 and get the critical points, right? So, no coffee. There we go. So that's the simplified form. And that's that.
Yeah, isn't it cotangent?
That's what I said. Pay attention. It's clearly COT right there. Can't miss it. Product rule, chain rule, quotient rule, they all apply, right? And if you know how to deal with the derivatives of this and make sure that the minus signs are in the right spot, all of these problems will be labeled rather annoying than hard, right? There's a difference between annoying and hard.
I think we've done the wrong form pretty much. I mean, it's basically supposed to be x squared, then it's going negative x squared ch cosecant h of x and cotangent of x plus by 2x cosecant h of x.
But it doesn't matter which one is first, which one is second, because they're added, right? As long as the negative is in front of the cosecant hyperbolic, cotangent hyperbolic, we can put that term first or second. It doesn't matter,
Okay.
right? Because remember that 1 minus 3 is the same as negative 3 plus 1, as long as you put that it's negative 3.
Okay.
Integration. Did I say derivatives here? No, I just started talking. Oh. So integrals are going to be the same formulas read backwards. So what is the integral of sine hyperbolic x dx? Plus c. There we go. See? That's the training we provide here. How about cosine hyperbolic x dx? Plus c. Nice. You peppered in the courtyard in there, trying to sneak that one. Where do you live, man? All right. How about tangent? What should we do there?
You should do 1 over 1 divided by 1 plus by x squared.
That's the inverse tangent function, but what is the integral? Well, let's leave it. Yeah, nope.
So 1 over a tangent inverse 1 over x over a.
But that's tangent inverse. So this, I'm asking for a tangent hyperbolic. It had nothing to do with it. Nope. Nope.
Secant square.
Nope. Nope.
Look in your book.
Nope. Well, yeah, you can. It's not a basic integral.
I don't want to hear it yet.
It's a U sub. It's a U sub problem, guys. Yeah, I know. It's gonna be ln. So I know it's awesome. We'll take care of that because that's the one you can do now. So integral of sine hyperbolic, cosine hyperbolic, integral of tangent hyperbolic is not a basic one. You have to use U sub to solve that one. So you have secant hyperbolic squared x dx. That's the basic one. And the answer to that one is?
Tangent.
Yeah, that's it.
Hyperbolic x.
Plus c. Integral of cosecant hyperbolic squared x dx is?
Cotangent.
Close. Negative, yes. Negative cotangent. Hyperbolic x plus c. And how about secant hyperbolic x tangent hyperbolic x dx? Negative secant hyperbolic x plus c, yes. Don't forget plus c. It really gets depressing without it. And how about cosecant hyperbolic x cotangent hyperbolic x dx? Plus c. Yeah. What, the plus c? Oh yeah, I know. All right. So, go. Do it. I want to see your U sub. What?
5, my math lab homework. You did this.
There you did.
Yeah. Wow, they drove the crap out of us. Not us.
Of course. ln cosine hyperbolic x. Okay. I like that one much better. Still incomplete. Plus c.
Thanks cotangent hyperbolic x plus c because like you flip when you did the u, you take the derivative, you flip them over and all stuff.
Okay, well let's see. I haven't solved it, so I have to do this. So I'm going to rewrite this as sine hyperbolic x over cosine hyperbolic x dx. And then what's u?
U equals
e to the x plus e to the negative x.
No, it's just cosine hyperbolic x.
Oh, but I did it wrong. I really don't. That's no fun, though.
This is tons of fun.
May I ask you, can I be able to like take the tangent as the u value instead, the entire tangent, and take it with me, or something like u equals tangent d?
No, because there's no building blocks for du in that case, right?
Yeah.
I just jumped right to the e line. It's that same exact one as you did, but then get that. And you have to choose one body. It's different when you do it. And you get that line instead of getting
So we get ln absolute u plus c, and then we say I don't care about u, I care about the x, which means we have to bring back the variable, which is ln of cosine hyperbolic x plus c. Now, I'm not really thrilled with this answer because see how tangent and cosine? It should be tangent and secant, right? Right? So, let's work some magic over here. What I'm going to do is I'm going to make the inside 1 over cosine hyperbolic x to the negative 1. So it's like putting two negative 1s stacking, right? So the first negative 1 flips to 1 over cosine, and the second negative 1 is the one that stays at a parenthesis. So I'll put this little step over here like this, so maybe it helps you. And now this negative 1 here I'm going to kick in front of ln, and the second one start to flip the fraction, so it becomes secant hyperbolic x, and then we have plus c.
Why are you doing the negative one again?
I don't think you have to.
Remember the pairing?
Yeah.
Pairing is always sine with cosine, secant with tangent, and cosecant with cotangent. And what your problem over there? Tangent ended up with cosine. And, right? So we keep it in a form that they're all in pair. Now, for purposes of calculating, right, you can use this, it will be fine. It just doesn't look nice, all right?
Yeah.
Like you have which way you put your hair, right? And that's the way, right? So the way is tangent with secant, and then we do a little bit of extra to force tangent secant pair.
But where's the negative one coming from? That's my question. Cosine equals x is 1 over. It does not work like that. The trig is
What do you mean negative 1? The negative 1, I put two negative 1s, they cancel each other out. Negative 1 has negative 1 plus 1.
And the second part, you have ln absolute value of 1 over.
1, you see these two ones? When you multiply them, you get 1, right?
Yeah.
So that's cool.
Yeah.
Now, this one over here goes 1 over cosine. And this one over here is the one over there. Now, this one floats in front, becomes this one. And the one that was inside made this into a secant.
I got
I love this stuff.
Is it all of it or?
Yeah, I hope you're not disappointed, but that's it. We have now problems that one thing that I won't bother you with are inverses of these guys, because they are extremely rare in application, and you will always be able to look up if you need, right? And you can look up any of this stuff except when you're on a test, but it will be too much to pile up on top of everything, still inverses. But they all have inverse functions. And I would like to actually put, since we are practicing integration and U sub and all of that, I would like to pick a problem from homework for this, so you guys can enjoy a little bit of that as well.
Do number 9, chapter 6.6.
No, this is from 610. We'll do that problem during the review. All right, let's see what you guys gonna hate over here.
It's got to be at least like half an hour. Screw it. It was better. Get it.
Wonderful example. 42. It's integral from 1 to square root of 3 of secant hyperbolic of ln of x divided by x dx. All right, see you next week.
Just wanted to actually going to fail his quiz and all. I'm not fully prepared for it and all that. So I just I hate computers. Getting a new one. Anyways, I said U equals ln of x, which is 1 over x. And then you cancel the 2 x's.
Keep going. You have a function to do this test. Thank you, says you do. I was waiting for you to do the other one. That's the season to walk on my phone. We go open the gate of hell. 7-2. And then you have 9 women. Yeah, well, you already completed that. Actually, no. That is awesome. That's my problem. Your issue, buddy. Yeah, your issue here. I wrote something. Now it's your problem. Go. Well, actually, what happened one day, it was just like random. One of the students from algebra class had the same clothes like on the same day. Like the black pants and the shirt was exactly the same with some black and gray sleeves. It was absolutely amazing, except she was a girl costume. But it was the same shirt. I had the problem with that costume. There was like different, but same shade, same black pants. And I think the shoes were always the same, but you know, like we picked it out. And so far twice, one of the department members, friend, had the same clothes as me the same day. You did? Yeah. So twice so far. He's been over 2 years now, and twice so far we had the same clothes on the same day. And then one night he was on a testing center. Pretty cool as well. Yeah, keep checking with people around you. Make sure everyone is on the same page.
I just want to say I believe this fall. Yeah, and then everything back.
You do. Oh my God. No.
How's it going? Memorize all of those? What are those? I can't see from here.
The integral of hyperbolic.
Why would you do that?
How does secant
Yeah, exactly.
Just like, I have a great poker face.
Oh, you're gonna love this stuff, I know. So what is secant? Secant is 1 over cosine hyperbolic, right? So we have 1 over x times, we're gonna love this, I know, we're gonna love this. It's 1 over x times 2 over e to the ln x plus e to the negative ln x dx.
Can you? Oh,
Yeah.
I got it.
When it's e is on top and 2 on the bottom, it's cosine. When it's 2 on top and e is on the bottom, it's secant, right?
So how can we
And then
tell it
because
I was
X is
correct
on
on
X.
that?
You are correct, but
In alternative form?
yep. So what happens here? ln x and p cancel out. You just leave x there, right?
Minus. Plus.
So we make like 2x then.
Plus 1 over x.
Plus 1 over x. Good. You see, you're getting somewhere. So this is the alternative form. You can do the u sub over there, but this is, I see this as much more fun to do it this way.
We might work here. Just saying.
So look, what do we get here? When you multiply this x through, and I guess, Kevin, this is your favorite integral? You mentioned it earlier? Yep. Such an awesome problem. Do what?
Where's the sine
Sine hyperbolic? There's no sine hyperbolic. Yes.
So, is it a general rule of thumb? If you're having trouble with it, like in the trig form, please break it down into exponents.
If you have the trouble and a problem in a hyperbolic form, you break it into e form. Yep, you can do that. Now, you can do this problem, guys, simply by using the u sub, right? U equals ln x, and then du is 1 over x. So it becomes the secant, right? Secant u. And the integral of secant is? Nope.
Negative secant hyperbolic x cotangent hyperbolic x.
That's the derivative. The integral is ln of secant plus tangent.
No, it's negative secant.
It's not a basic integral, Kevin. It's not a basic integral. It's a component. Integral of secant is not on your list. If you look at where are your formulas for integrals? Right? None of these things are none of the basic formulas are secant. So you have to use the ln form, which is a little bit more annoying to compute. So everything up to the point where you did that is correct, and now you just have to use the other formula, which is more challenging to do. But this form is very quick. So this problem was designed by whatever torturer to just get this lecture across that you can use whatever form is more convenient for you to solve the problem. What's the inverse tangent of root 3? Very good. All good.
Just want to say, I believe I probably be able to figure out what the if we do want order cosine hyperbolic of h of x, then we use the ex plus by e to negative x divided by 2 to flip it over, and then we can probably cancel out the, or we can like reduce it down from there.
Yes, that's exactly what happened here. So that's a way. That's one of the ways to deal with this. So guys, that's it. And as you can see, we did some of the U sub and some of the stuff. I'm just going to go now, restart the stream for 7.1 to talk about integration in general, which is introduction into chapter 7. Now in 7.1 we don't learn anything new. We are technically reviewing. We are only going over the basic integrals and over the U substitution with the back substitution as a possibility as well. And then we'll have more specific questions hopefully for the review portion later on. So I'll restart the stream.